Hi students, in today's video we are going to discuss about isomerism isomerism in alkane isomerism in alkanes. Students, in our last video we discussed about nomenclature of alkane. In today's video we are discussing about isomerism. First of all, we must have to know what is meant by isomerism, and then what kind of isomerism is exhibited by alkane. So student, it is known to us that in organic compound isomerism is most common. In case of organic compound, one molecular formula represents more than one compound, and that more than one compound having same molecular formula but different properties are termed as isomers of each other, and the phenomenon is known as isomerism. More precisely, we can say that two or more compounds having same molecular formula but different properties are known as isomers of each other, and the phenomenon is known as isomerism. In case of organic compound, two main classes of isomers are there. One is structural isomers and another is stereoisomers. Now, what are structural isomers? In this case, two or more compound have same molecular formula but different structural formula. Means their two-dimensional arrangement of atom is different but they have same molecular formula. Such isomers are termed as structural isomers. More precisely, we can say that two or more compounds having same molecular formula but different structural formula are known as structural isomers of each other, and the phenomenon is known as structural isomerism. Now, this structural isomerism is of different five types. One is chain isomerism, second one is positional isomerism, third one is functional group isomerism, fourth one is metamerism, and fifth one is tautomerism. Now, the isomerism exhibited by alkane are chain isomers and positional isomer. Alkane do not exhibit functional group isomerism, metamerism, and tautomerism. Now, what are chain isomers? Two or more alkane having same molecular formula but different carbon chain present in them are termed as chain isomers of alkane. Means there are examples of alkane. We know that general molecular formula for alkane is Cn S2n plus 2. N is greater than or equal to 1. If N is equal to 1, we get molecular formula CH4, and it has only one structure, that is carbon is tetravalent, which is joined to 4 hydrogen by 4 single bonds. It has only one structure. This cannot be arranged in different manner. So we can say that methane does not exhibit isomerism. Another member of alkane series is N is equal to 2, that is ethane. It has molecular formula C2S6. In this, while writing structure, we can write two carbon atoms. Carbon is tetravalent, one bond is already there. So we have to write here 3 hydrogen for each carbon. So CS3. So this C2S4, C2S6 formula permits only one structure. So we can say that ethane also has no another isomer. Then come to third member, that is N is equal to 3 propane. It has molecular formula C3H8. Now here structure of this propane can be written like this. 3 carbon atoms are there, and for tetravalency we can write appropriate number of hydrogen. Here CH3, this one is CH2, CH3. Now this propane also has no another structure. From these three examples we can state first three members of the alkane series, that are methane, ethane, propane, has one molecular formula and one structural formula. Therefore, they do not exhibit any kind of isomerism. Then come to next member of alkane series, that is N is equal to 4 butane. Its molecular formula is C4H10. Now this molecular formula permits existence of two different alkanes, one having straight chain of carbon and another having branching of the carbon. Both are C4, but here 4 carbon atoms in longest chain, here 3 carbon atoms are in longest chain and one is in branching. Its molecular formula is C4H10 and structural formula can be written CS3, CH2, CH2, CH3, condensed formula. And for this CH3, CH, CH3 and CH3. Bond line formula can be written here. 4 carbon atoms are there. We can write number 1, 2, 3, 4 and join this point. This is bond line formula for this compound butane. N-butane, we can say that. We learn about nomenclature. In common name, this compound is known as N-butane, and this compound is isobutane. Its bond line formula will be like this. 3 carbon atoms are in longest chain. So we can join these point, and this branching can be shown here. So both these compounds have same molecular formula, that is C4H10, but they are differ in the nature of carbon chain. One has straight chain of carbon and one has branched chain of carbon. So they are differ in the nature of carbon chain. Therefore, we can say that they are the examples of chain isomers. Means this N-butane and isobutane are the examples of chain isomer. So isomerism in alkane starts from the alkane containing carbon 4 or more than 4. J means N is greater than or equal to 4. Then and then we can observe isomerism in alkane. Here methane, ethane, propane does not exhibit isomerism. So this C4H10 has two isomer. Then what about the next member, that is N is equal to 5. Formula will be C5H12. So 5 carbon atoms are there. First we'll write 5 carbon in longest chain. 2, 3, 4, 5. We'll join them. This is pentane. If we write 4 carbon in longest chain and one is on branching, so formula becomes like this. Both are 5 carbon containing alkane. Both will have formula C5H12. Here this compound is N-pentane and this one is isopentane. Another isomer is also possible for this C5H12. we can reduce the chain up to 3 carbon atom, and we can write 2 branching of methyl group on second carbon. So this is N-pentane, this is isopentane, and this one is neopentane. So these N-pentane, isopentane and neopentane are the different isomers of the molecular formula C5H12, and these are differ in the nature of carbon chain, therefore they are chain isomers of each other. Now student, it will take time to calculate how much chain isomers are there for the given alkane. We we can say that first three members, that are methane, ethane, propane, have no any isomer. One molecular formula represent only one structure. Butane has two isomer, N-butane, isobutane. Pentane has three isomer. If we write hexane, we'll get till more number of isomers. To draw the each isomer and calculate their number, it will consume much more time. There is trick for calculating the number of isomers for alkane. The formula for calculating number of isomers is 2 to the power n minus 4 plus 1. This formula is useful for calculating the number of isomers, chain isomers for alkane containing carbon or N 1 to 7. If N is equal to 1, how many isomers are there? So we can write N is equal to 1. We can write 2 to the power 1 minus 4 plus 1. What will happen here? 2 to the power minus 3 plus 1. If power is minus, then neglect that number. Then which number remains? 1. Means one carbon containing compound will be only one, that is, it will not have any isomer. If n is equal to 2, means two carbon atom are there, then we can write 2 to the power 2 minus 4 plus 1, will get 2 to the power minus 2 plus 1. So here negative power, neglect this number, only one compound is there. Means for methane only one is there, for ethane only one is there, means there is no another isomer. CH4 represent one structure, C2H6 represent one structure. If we take N is equal to 3, N is equal to 3, then we'll get formula 2 to the power 3 minus 4 plus 1. Here also we get 2 to the power minus 1 plus 1. So this negative power we have to neglect the number. So only one is there, means propane also have only one structure. Means by using this formula 2 to the power n minus 4 plus 1, we can say that methane, ethane, propane has only one structural formula, means has no any another structural isomer. So we can say that methane, ethane, propane does not exhibit any kind of isomerism. Now if we take n is equal to 4, then by keeping the value of n in this equation, we will get 2 to the power 4 minus 4 plus 1. Now here 2 to the power 0 plus 1, and for any number if its power is 0, that becomes 1. So 1 plus 1 is equal to 2, means butane will have two isomer, and that we already discussed, that is N-butane and isobutane. This indicates that this formula works better. For 5 carbon containing compound, we have to keep their N is equal to 5, means 2 to the power 5 minus 4 plus 1. 2 to the power 5 minus 4 means 2 to the power 1 plus 1 means 3. Means for alkane containing 5 carbon will have 3 different isomer that we already discussed. N-pentane, isopentane and neopentane are the different isomers for C5H10. Now for 6 carbon containing compound, here we can make table N and number of chain isomers. For N is equal to 1, number of isomer 1, N is equal to 2, 1, N is equal to 3, 1, N is equal to 4, 2, N is equal to 5, 3. For N is equal to 6, we keep N is equal to 6 here, minus 4 plus 1 will get 2 to the power 2 plus 1, that is 4 plus 1 is equal to 5. So we can say that alkane containing 6 carbon will have 5 isomers, 5 different isomers. If N is equal to 7, then we have to keep N is equal to 7 in this formula. So 2 raised to 7 minus 4 plus 1 will be equal to 2 to the power 3 plus 1. 2 to the power 3 is 8. 2 into 2 4 into 2 8 plus 1. So total 9 isomers, means heptane will have 9 isomers. Now this formula, which number of isomers is equal to 2 to the power n minus 4 plus 1, works for the alkanes having carbon number 1 to 7. For 8 carbon, another formula is there, and that formula is same. We have to use a plus 1 instead of plus 1 plus 2, means that is for 8 n is equal to 8, we have to use formula 2 to the power n minus 4 plus 2, that is 2 to the power 8 minus 4 plus 2, means 2 to the power 4 plus 2, and 2 to the power 4 is 16 plus 2, that is 18. So octane will have different 18 isomers. And for 9 carbon, for 9 carbon means for 8 we have to use this formula, and for alkane containing 9 carbon we have to use another formula. That formula is 2 to the power n minus 4 plus 3. For 8, for 1 to 7, n to the 2 to the power n minus 4 plus 1. For n is equal to 8, 2 to the power n minus 4 plus 2. For n is equal to 9, formula will be 2 to the power n minus 4 plus 3. So we can calculate 2 to the power 9 minus 4 plus 3 means 2 to the power 5 plus 3. 2 to the power 5 is how much? 32 plus 3, that is 35. So alkane containing 9 carbon will have different 35 isomers. And for n is equal to 10. The formula is, this is for n is equal to 9. For n is equal to 10, formula is 2 to the power n minus 4 plus 1 plus number of carbon means 10. This one is original 1 to 7 formula. In that we have to add 10 number of carbon. So for 10 it will become 2 to the power 10 minus 4 plus 1 plus 10. 10 to the power minus 4 means 10 to the power 6 plus 1 plus 10. 10 to the power 6 means 2 to the power 6 is how much? 64 plus 1 plus 10, that becomes 75. So we can say that alkane containing 10 carbon will have 75 different isomers, or we can say that the total number of isomers up to 9 carbon also becomes equal to total number of isomer shown by only one alkane, that is decane. Here see 5 plus 8, 13 plus 9, 22 plus 5, 27 plus 3, 30, 31, 32, 33, 34, 35. Here 5, carry 3, 3 plus 3, 6 plus 1, 7. Means number of isomers shown by only one alkane, that is decane, is always equal to, it is found that always equal to different isomers shown by the alkane containing 1 to 9 carbon. So total number of isomers shown by decane are 75. So these are the few tricks. Without writing different structure, without consuming more time, we can calculate number of isomers by using simple formulae. While concluding this lecture, I can say here for 1 to 7 this formula 2 to the power n minus 4 plus 1 will get number of isomers. For n is equal to 8, the formula 2 to the power n minus 4 plus 2. For n is equal to 9, formula is 2 to the power n minus 4 plus 3. And for n is equal to 10, 2 to the power n minus 4 plus 1 plus number of carbon, that is 10. And onwards also we can calculate by using this formula. For 11 we have to write here 11, for 12 carbon we have to write here 12. Accordingly we will get number of different isomers exhibited by alkanes. So student, these are the different chain isomers shown by alkanes. So I hope you understand isomerism in alkane. We'll stop here. Thank you.